हेलो, वेलकम टू बियॉन्ड स्टडी। आज हम देखने जा रहे हैं अनलॉकिंग हाई डायमेंशनल डाटा, द पावर ऑफ t-SNE। आज के समय में जब भी हमको बहुत बार जब होता है कॉम्प्लेक्स डेटा सेट्स के साथ डील करना होता है जो कि हंड्रेड्स या इवन थाउजेंड्स ऑफ द डायमेंशंस में होते हैं। तो इन डाटा को कैसे समझे, क्योंकि हम ऐसे नॉर्मली तो इनको समझ नहीं सकते, तब हम t-NSE का यूज करते हैं। हम अब इस पूरे वीडियो में एक्सप्लोर करेंगे t-NSE कैसे काम करता है, क्या कॉम्प्लेक्स डाटा को कैसे सिंपल बनाता है, कैसे विजुअल इंसाइट्स को इजीली करता है। तो अब बात करते हैं व्हाट इज टी-NSE। टी-NSE होता क्या है, ठीक है। सो अब t-NSE have a t-distributed stochastic neighboring embedding. It is a non-linear dimensional reduction technique, means it can capture the complex patterns that linearly method like PCA can't. It helps to visualization high-dimensional data in 2D or 3D discovery hidden patterns, identify the clusters and relationships. In a simple term, t-NSE turns the complicated data into something which we can actually understand. Now, let's talk about the core idea behind it. First, it converts the distance between the two data points into the probability and representing similarity. It tries to preserve these similarities when the mapping data to lower dimension. To solve the problem of overcrowding, it uses something called I-student t-distribution. This ensures that points don't collapse into one dense cluster, remain well separated. Now let's talk about how t-works work. Let's understand how the t works step by step. Step 1, it constructs the probability distribution based on the similarity between the data points. Step 2, similar points get higher probability values while the dissimilar points get the lower value. Step 3, the perplexity parameter is used to balance the local and global structure. Think of perplexity as deciding how many neighbors each point should consider. Now let's talk about the further steps. In the next stage, t-SNE works to two complex probability distribution, one over the high dimension space and one from the low dimension space. It uses the Kullback-Leibler divergence to measure the difference between them. Then using the gradient descent, it minimizes this difference step by step. Finally, it produces a map where the similar points from the cluster revealing the structure of data. Now let's talk about the key features and their impacts. First is perplexity. It controls the balance between the local and the global pattern, typically values from the 0 to 55 or 5 to 50. Second, learning rate. It controls how fast the model runs, and too high cause instantly stability, too low makes it slow. Third, initialization. The starting point of the algorithm, it can't be random. For or the PCA based, different initialization can be different results. Now let's talk about the practical applications of this. t-NSE is widely used in the many real-world applications in NLP, in genomics, in image analysis, and business. In business, it is used as a customer and segmentation and behavior analysis. Image analysis may it is used for the learned by the neural network. Genomics may it identify the disease patterns, and NLP it helps to visualize the world embedding. Now let's talk about the common pitfalls and how to avoid them. First, don't assume clusters are always meaningful. They need validation. Second, results can change based on the parameters like perplexity. Third, some patterns may be artifacts of the optimization, not real data structure. Also, the distance between the clusters are not always meaningful. Focus on the local relationships. Now, let's talk about the best practice to use it. Try multiple perplexity values to understand your data better. Use PCA before t-NSE for faster computation. Combine t-NSE with other techniques like clustering or UMP. And most importantly, treat the result or guide as a guide, not an absolute truth. Then let's talk about the future of the t-NSE. The future of the t-NSE looks promising. It is being integrated with the deep learning model for the better interpretability. Real-time visualization is becoming possible with the streaming data. And now, new scale versions are being developed to handle the massive datasets. To conclude, t-NSE is a powerful tool that helps us to understand the complex and high-dimensional data through the visualization. It reveals patterns, clusters, relationships that are otherwise difficult to detect. Your journey into the high-dimensional data exploring starts here. Thank you for watching.